So we're going to look at probability using combinations and permutations. And first question, the coach of a co-ed dodgeball team must select 5 players to start the game from a team that consists of 6 females and 5 males. How many ways can this be achieved if the coach must first of all choose 5 females and no males to start the game? So we'll consider that one first, and then we're going to go through all the other possibilities for starting females and males to determine the total number of ways that this can be achieved. So first of all, the number of ways that the coach can choose 5 females is 6 choose 5, and the number of ways that they can choose 0 males is 5 choose 0. Now, the number of ways to choose a starting lineup is going to be 6 choose 5 times 5 choose 0. And there are 6 ways that you can choose the 5 females. And if you want to think of it, you've got 6 females. There's 6 ways you can leave one of those 6 females out of the starting lineup. Now, there's only one way that you can choose 0 males, and that's by not including any. So then the total number of ways is going to be 6. So next, 4 females and 1 male to start the game. To choose 4 females out of the 6, and since order doesn't matter because there are no positions in dodgeball, then there are 6 choose 4 ways to choose the females, the 4 females, and 5 choose 1 way to choose the 1 male. So there are going to be 6 choose 4 times 5 choose 1, and this works out to be 15 times 5, and the 5 makes sense because if you're going to have 1 male, you have 5 different choices for that 1 male. And for every one of those 5 choices, there is 15 choices for choosing the 4 women. So the total number comes out to be 75. So next, choosing 3 females and 2 males, there are 6 choose 3 ways to choose the 3 females, and 5 choose 2 ways to choose the 2 males. And so then that works out to be 6 choose 3 times 5 choose 2, and these are combinations again. And so this is 20 times 10, which is 200 ways that you could choose a starting lineup with 3 females and 2 males. So next, the number of ways you can choose a starting lineup that has 2 females and 3 males. The number of ways you can choose the 2 females is a combination of 6 choose 2. The number of ways that you could choose 3 males out of the 5 is 5 choose 3. And so this is going to be the combination of 6 choose 2 times 5 choose 3 in the number of ways we get out of the starting lineup. And this is equal to 15 times 10, which is 150. Number of ways that we could choose 1 female and 4 males to start the game. You can choose 1 female, 6 choose 1 ways, and this is going to be 6 because you have 6 females to choose from, and there are 6 ways you can pick one of them. You can choose the 4 males in 5 choose 4 ways. So the number of ways we could have a starting lineup is 6 choose 1 times 5 choose 4. And this works out to be 6 times 5, which is 30. And the 5 here makes sense because 5 choose 4. Well, you've got 5 males, and you're going to leave one of them out in for every lineup. So there's going to be 5 ways that you could leave one of the 5 males out. And that's 30. Lastly, the number of ways you could choose 0 females is 6 choose 0, combination of 6 choose 0. And the number of ways we could choose the 5 males is 5 choose 5. And this comes out to be 6 choose 0 is 1, and 5 choose 5 is 1. And that also makes sense because you've got 5 males. There's only one way that you can pick all 5 to start the game. And so this comes out to be one way that this could happen. So next question, what is the total number of ways that the coach can choose a starting lineup from the 11 players? there's a couple ways you could do that. First of all, you could add up all the answers we just had from five females and 0 males, plus the number of ways you can choose 4 females and 1 male, plus the number, and so on until you get to 0 females and 5 males. So these were the answers that we had previously, and if you add those numbers up, you should get 462. The easier way to do this would have been to do the combination of 11 choose 5, and remember it's a combination because order that the people are chosen, or the position, they'd have no position, so order is not important. So this is the combination of 11 choose 5, which is 11 factorial over 11 minus 5 factorial times 5 factorial. And that simplifies to be 462. Part B, if a coach randomly selects 5 players, what is the probability that the coach will select 3 females and 2 males? So first off, if we look at the number of ways you could pick 3 females and 2 males, well, you have 6 females to choose from, so that's going to be the combination of 6 choose 3, and 5 males to choose from, so you're going to pick 2 of them, so that'll be the combination of 5 choose 2, divided by the total number of ways that the coach can pick the team. And so this comes out to be 20 times 10 over 462, which is approximately 43.3%, or 0.433. Now, if the coach is going to select at least 2 females, well, there's a couple ways you could do this. You could add up all of these, because this is the number of ways that the coach could pick 2 females times the number of ways that the coach could pick 3 males, plus the combination of 6 choose 3. So that's the number of ways that you can pick 3 females out of the 6, times the number of ways that you can pick 2 males out of the 5, plus this would be the combination of 6 choose 4 times 5 choose 1, which is the number of ways you can pick 4 females out of the 6 and 1 male out of the 5, plus 6 choose 5, which is the number of ways you can pick 5 females out of the 6 times the number of ways you can pick no males, and this comes out to be 431 over 462. Now this would have been easier if you had done 1 minus the number of ways. So you could have calculated the number of ways you could pick 0 females and 1 female, and subtracted that from 1. So the number of ways you can, of the probability that the coach will select 5 males will be the combination of 6 choose 0, which is the number of ways you could pick 0 females, over times 5, the combination of 5 choose 5, which is the number of ways the coach can pick 5 males out of the 5, over the combination of 11 choose 5, which is 1 over 462, which is approximately equal to about 0.22%, or 0.0022.